In this section we discuss redirection. Now within a Linux environment, redirection defaults to three file descriptors. File descriptors 0, 1, and 2. And file descriptors 0, 1, and 2 correspond directly to defaults of keyboard, screen, and standard error. Let's show you what we mean. Let's open a shell. By default, anything that's echoed is echoed to the screen. This is considered standard output to the file descriptor 1, which is the keyboard. When we type commands, good or bad commands, using the keyboard, we're making use of file descriptor 0, which is considered standard input. So the standard input for a computer is the keyboard. So in order to execute commands, or in order to instruct the computer to perform functions for us, such as executing commands, we typically use standard in, which is the keyboard. We type the command such as ls, it lists the directory or cd, going to temp2, it does it for us, etc. So that's standard in and out, and standard error, any errors that are essentially received or echoed from a shell script, a binary, an application, can be captured and recorded. Now, to show you some simple examples of how standard input works, let's echo using standard in, hello world, to standard out, which is the screen. So we've used standard in, which is the keyboard, to type in the command echo and to read from the command line hello world, and it was echoed to standard out, with no errors of course, so we're not making use of the file descriptor number 2, which is standard error. We're simply using 0 and 1. And for the most part, we usually use standard in and standard out, file descriptors 0 and 1. So that's a simple echo of a hello world. How about if we were to LSL the entire etc directory? Standard in is retrieved from the keyboard. Standard out is where the results are returned. That's how we interact with the shell. Linux treats the file descriptors distinctly: in, out, and error. Now we can show you some examples of using standard in with common commands such as cat and grep. Cat is a command that will concatenate for you, but it'll also read a text file and dump the output of the text file to the screen. So let's say, for example, we had a text file in this directory, and we do. Well, we'll touch a new one. We'll create a file, and this file will be called hello world, and we'll give it an extension of .text. We'll use an editor such as VI to modify hello world. We'll press I for insert, and we'll simply type hello world. It's not a script, so it doesn't need to have the appropriate headers indicating that it's a bash script. So we now have a new file called hello world.txt. If we were to cat and redirect the standard input using the less than sign, the contents of hello world, the contents will be echoed to the screen, as you see here. The standard symbol within a Linux and Unix environment, or Unix environment, for input redirection is the less than sign. On the left, you have the command that is to run, such as cat, separated using the less than sign by the command that is to be fed into the input stream. So redirection allows you, especially when you're dealing with standard input, allows you to redirect the input stream for a command to another location, such as a file. Typically commands accept, such as cat, grep, you name it. Cat's one of the exceptions, but typically commands accept input streams from standard in, which is the keyboard. So typically you type a command such as ls, and it expects an input stream from the keyboard, such as specifying a default directory, perhaps of /bin. This is the input stream being controlled from standard in, the keyboard, and it lists the directory. Now bash does some defaults for us. Of course, it'll nicely, if we don't specify on standard in, it'll list the default directory. So typically commands expect input to be fed using standard input, which is the keyboard, but some commands can use or redirect accept redirects from files, which means you can create text files or files which contain commands and have your binary or shell script redirect using the input of that particular file. So that's a way to move the input stream or to control the input stream from the standard keyboard. Excellent. So you have an idea how standard input works. Let's show you another example. Now within the file hello world, we'll cat it again, hello world.txt, we can find two strings, or we'll find two strings, hello space world. We can use grep, which is a parser. It's a line parser. It searches for words within rows within a text file. And we can use grep, for example, to search for the word hello and redirect the standard input to the file hello world.txt. So grep will search for the word hello. It'll accept its input, so it'll modify its input stream to receive input from the file hello world.txt. Hello world.txt could contain multiple lines, but in this case it contains simply one line. Nonetheless, the shell will redirect the input stream. Now watch. Grep returns the line which contains hello world. Grep searches for matching strings, and then it returns the entire row. Let's elaborate a little bit. Let's modify the hello world text file, and we'll add another line. And we'll exit. So now the hello world file, if we're to cat it, which should be somewhere in the history, now contains two lines. Let's run that grep again using hello world as the input stream file. You'll see that only one line is returned, the line which contains the text hello space world. Pretty neat. So we're able to parse and we're able to redirect input all at the same time. Grep is the parser and the shell performs input redirection. Now let's turn our attention to output redirection, because for the most part you'll find that binaries and scripts that are provided by third parties, or the majority of them that come with your typical Linux distribution, usually has distinct ways of accepting input from other files or outside files. So typically they're parameters such as -f or -f, -a or "I", some other argument that you can pass into the command so that it accepts its input from a particular file. And sometimes those files need to be formatted in a specific way. So to make a long story short, you're likely to make more use of standard output or redirection of standard output than you are to make use of redirection of standard input. So what we should be focusing on is working with the hello world text file to show you how to move output around. Let's show you some examples. Now, if you recall, hello world.txt contains a few words, including hello space world and where space here. Let's say we wanted to cat the contents of hello world.txt. Now, by default, standard input is where? Standard input is the keyboard. So cat will read from the keyboard hello world.txt, which happens to be a file, and it cats the contents to standard output, which is file descriptor number 1. Standard output is actually the screen. So when we instruct the shell to run cat and operate on the file hello world.txt, by default cat accepts on standard input its standard input stream from a file. So it operates on a file by default. So it's optional to actually specify the less than sign. But the less than sign is important for you to know because it's the standard representation for redirecting standard input. So back to standard output. We've catted the contents of hello world.txt and it was echoed to the screen, which is the file descriptor 1. What if we wanted to redirect the contents of hello world.txt to another file? Well, we can control output redirection. Simply cat hello world.txt, use the greater than sign, and this will send the output instead of to the screen to a file. Now we need to simply specify a file name such as hello world, and we'll call this file 2, hello world2.txt, which does not exist. As you just saw, I used tab completion, which is a bash feature, to tab hello world out quickly, and if there were a similar file, it would have prompted us, the bash shell would have prompted us for clarification. So we're going to take the contents of hello world.txt and send it to this new file, hello world2.txt. Now this is a long way of doing a copy of the same file, but you'll see it gets much more complex because we can make use of pipes when we look at the pipe section to parse specific lines, specific words from files to extract, in other words. So from the hello world.txt file, we may want to parse just the word hello, or the row which contains hello world, or maybe the second row which contains the word here, and send it to a separate file for parsing purposes. But nonetheless, let's continue to show you the basics. Now we've created a hello world2.txt. If we LSL, you'll see that there's a hello world2.txt. It's the exact same byte size as hello world.txt. We can likewise cat hello world2.txt. It contains the same thing. The standard output is real easy to understand. You simply read a file or something from the keyboard and send it to another file. Let's show you an alternate way to make use of standard output. We're going to actually append to a file. Hello world2.txt is now equivalent to hello world.txt. They're both 23 bytes. Let's run that cat command again, but instead of one greater than sign, we'll put 2. When you indicate using 2 greater than signs, you instruct the bash shell to append to the file that you have in question. If the file does not exist, the bash shell will create the file. Well, hello world2.txt actually exists, so the bash shell will simply append to the file the 2 new lines that are found in hello world.txt. Let's show you how that works. Now if we LSL, you'll see that hello world2.txt is now twice the size of hello world. And if we were to cat the contents using input redirection of hello world2.txt, you'll see it contains the same rows twice. Hello world, we're here twice, because we've made use of output append redirection with 2 greater than signs. If we had 1, it would simply overwrite the file. Let's show you how that works. We'll use 1, and now you'll see that hello world2.txt has moved from 46 bytes back to 23 bytes. Because if the file already exists and you specify 1 greater than sign, the file gets created and overwrites the existing file. So it's always safe to do an append like this. Now let's show you how the append works with a totally new file, hello world3.txt, which is a file which certainly doesn't exist. Now if we LSL, you'll see that although it didn't exist before, it's now created. So input redirection makes use of the less than sign. Output redirection by default makes use of the greater than sign. And if you want to append, you make use of double greater than signs, and you're able to append to a particular file. You can take the output from one file and append to another file. Let's show you a little more complex example. Now if we were to cat the contents of hello world.txt, you'll see it contains 2 lines. Let's use grep to find here, which is located in the second row. We'll grep here from hello world.txt, and if we were to simply press enter, it returns that particular row or line to the screen. But let's get fancy. We'll send this to a new file called hello world4.txt. And now we have a file called hello world4.txt, and if you notice, it's only 11 bytes. If we're to cat the contents of hello world4.txt, it contains just the line we're here. And the same applies. We can do this twice. Just simply change the redirection to append. So what's happening here is as follows. We're making use of bash's power. We're running one command to find the here string from a file called hello world.txt. Now the less than sign is optional because grep expects to search a file, but we're showing it for clarity. We're searching hello world.txt for a line which contains here, and in the first instance we created a new file called hello world4.txt. In this instance we're going to append to hello world4.txt. Now the file should be 22 bytes, and it is. If we were to cat hello world4.txt, it now contains 2 lines which are identical. So that's a simple example of actually parsing one file and redirecting using append or creating a new file. And conversely, if we were to take off the append redirector and simply specify 1 greater than sign, the file gets overwritten hello world4.txt and gets reset to 11 bytes, which was the original size of the file. So be careful how you use the greater than signs, because you could overwrite pretty big files very, very easily. So input redirection and output redirection are very easy to understand. They're critical for shell scripting because we're constantly taking strings from one file and sending them to another. We'll be looking at pipes next to show you how to connect the output stream of command A to the input stream of command B, and so on.